Okay, hello everyone. Welcome back to the lesson for acids and bases. Now, first things first, acids and bases is a chapter that's taught to you in Sec 3. So why bother learning about acids and bases? Now, the idea behind chemistry in the first place is to learn the behavior of different chemical substances. So for instance, water is a chemical substance, carbon dioxide is a chemical substance, sodium hydroxide is a chemical substance, right? So we want to know how these substances will behave. And the way to learn how they behave is to categorize them into different groups. So acids and bases just happens to be two opposite groups of substances. All right. In fact, many things around us are either acidic or basic. And some of these are very common everyday substances around you. Take, for example, if you look at vinegar, vinegar that's used in food is acidic. On the other hand, the cleaning detergent used to clean the floor, clean dishes, it's almost always basic. Okay? So now we need to go into the theory. So what is acidic? What is an acid? Now, acid is a substance that produces hydrogen ions. So hydrogen ions are H plus ions when dissolved in water. Now, this is a really key statement to make. So there are two parts here. Number one, acids must produce this particular ion, H plus ions. Secondly, the acid must be dissolved in water. All right. Okay. Okay, so of course, this leads us to the three common lab acids you have in the lab. So we have hydrochloric acid, HCl. We have nitric acid, HNO3. And finally, we have sulfuric acid, H2SO4. All right, so these are the three common acids you have in the lab: hydrochloric, nitric, sulfuric acid. So how then do you show that they produce H plus ions? Well, you can do so by just showing how they form H plus. Okay, so you can quite clearly see all three of them will produce H plus. For instance, HCl when dissolved in water, HCl when dissolved in water will form H plus and Cl minus. All right. Okay. Now, so you have learned as well, Cl minus has a name. Cl minus is called chloride. And that's the reason why, if I use hydrochloric acid as the acid, the salt form must end with a chloride in its name. Okay? We can do the same for nitric acid. Okay, basically nitric acid must be dissolved in water. So it's aqueous, and it forms H plus as well as NO3 minus. So again, NO3 minus has a name. That's the nitrate. And that's why if I use nitric acid, the salt form is a nitrate. Okay? And finally, the last one. Now, sulfuric acid is the one that you must be a bit more careful. I think my 3 contribute students will know this once I've tested you in the test. It still forms H plus. Despite the formula being H2SO4, it still forms H plus because it's an acid. The only difference is now it forms twice the amount of H plus. This means that if I have one H2SO4 molecule, it will form 2 H plus, double the amount. And of course, SO4 2 minus is called sulfate. And that's why if I use hydrochloric acid, I get the chloride. If I use nitric acid, I get a nitrate. And finally, if I use sulfuric acid, I get a sulfate. These are the 3 common acids that you need to know. And you will realize the salts that you have learned will always be chlorides, nitrates, or sulfates. So this is the relationship. Okay, so we have covered the definition of acids. We have covered the equations to show how acids can form H plus. Now, both can be asked in the O levels. Okay, so please take note how to write these equations to show how acids dissolve in water and form ions. Lastly, we have also covered how the different acids give rise to different salts, chlorides, nitrates, and sulfates. Okay, so let me just pause the recording for a while to ensure that all of you are following. Okay, so moving on, let's go through acids. What are some properties of acids? Now, I'm sure you know by now, there's physical properties and there are chemical properties. Now, physical properties have to do with your five senses. Take, for example, sense of sight. Okay, so I'm sure you know by now acids. Acids will turn moist blue litmus paper red. Okay, so we have experienced this before. Acids turn moist blue litmus paper red. So this has to do with sense of sight, right? A color change. Now, besides that, acids, they can turn universal indicator into different colors. So they can turn universal indicator red, orange, or yellow. Okay, so whether it's red, orange, or yellow depends very much on the pH. Red is pH 1 to 2, orange is pH 3 to 4, and finally yellow is pH value 5 to 6. So this is relatively simple to remember because it's 1 to 2, 3 to 4, 5 to 6. Okay, so your lab acids like HCl, HNO3, these will all fall into the red category because they are strongly acidic. So all three acids in the lab will have a pH of around 1. That's why they will turn universal indicator red. Okay, so these are physical properties because they involve a color change which can be observed by your sense of sight. Okay, now besides that, you have learned that acids taste sour. So this is another one of your five senses, right? Sense of taste. Finally, acids have pH less than 7. Okay, the pH value of acidic solutions must be less than 7. Right? I think these ones you know. Okay, so just to share, we have divided our paper hopefully into like two. There's acids and bases. So now we are at acids. Okay, so now we have summarized the definition of an acid. We have summarized the physical properties of an acid. Now, lastly, we'll talk about the chemical properties of an acid. Okay, the chemical properties, of course, is what we are very much interested in because we need to know how acids will react. All right, so we have just completed the physical properties of acids. Let's move on to the chemical properties of acids. So chemical properties means chemical reactions. We need to know what the reactions are. The first reaction, acid plus metal. Acid plus metal forms salt and hydrogen gas. All right. Now, I'm sure you know by now, metals always give you hydrogen gas. So the gas formed from a metal must be hydrogen. And you need to know how to test for hydrogen. Right? To test for hydrogen, we make use of a lighted splint. Okay, so we introduce or we insert a lighted splint into the mouth of the test tube. The gas extinguishes the lighted splint with a pop sound. Okay, so it's important to know the gas test. So for the Sec 4 and 5 students, I'm sure you know by now, you absolutely have to know the gas test because this is also related to QA. It's related to your practical, it's related to theory, so please learn it. So for the Sec 3s in this group, okay, take it as a second chance for you to learn the gas test thoroughly before you move on to Sec 4. Okay, so alongside this, you also need to learn the equations. Now, it's very helpful whenever you're summarizing a reaction to give some example chemical equations. What do I mean? So you know it's acid plus metal forms salt and hydrogen. So choose any acid, let's say HCl, hydrochloric acid. Then you choose a metal, magnesium. So HCl plus magnesium forms what? So it forms a salt. So now you're going to decide what is the salt. The salt must always start with a metal in its name. The metal is magnesium. So it's magnesium what? So you got to think, you have used hydrochloric acid. So just now we said, if you use hydrochloric acid, the salt ends with chloride. So the salt must be magnesium chloride. Then please don't just immediately write MgCl. It's not MgCl. You need to think of the formula first. And to write the formula correctly, you need to first think of the charges that each of these will form. So now look at the periodic table. This is where the periodic table comes in, right? Magnesium is from which group? So if you search in the periodic table, magnesium is from group number 2. If magnesium is from group 2, it has 2 valence electrons. It will lose the 2 electrons to form Mg2 plus. On the other hand, Cl, chlorine, if you look in the periodic table, chlorine is on the other side of the periodic table. Specifically, chlorine is found in group 17. 17 means it has 7 valence electrons. 7 valence electrons means it will gain 1 valence electron to form Cl minus. So once you have written out the charges as you're working, it's not the final answer, you got to think Mg2 plus and Cl minus means that it will form MgCl2. All right. Can. Now, it's very important to write the correct formula. If you don't write the correct formula, no matter how hard you try to balance the equation, it will still be given a 0 mark. On the other hand, if you have written the formula correctly, MgCl2 plus H2, you get 1 mark, even if the equation is not balanced. So please spend some time, look in the periodic table, where's magnesium, where's chlorine, then figure out the charges that it will form. Okay, and if you're unsure why it's 2 plus and why is it minus, please watch yesterday's lesson video, which has been given to you. Okay, so now if you look, the equation is not balanced because you have 2 chlorines on the right. It's MgCl2. You needed 2 chlorines because it's 2 Cl minus for each Mg2 plus. So to balance the equation, quite clearly, I would need to balance the chlorine. So how would I balance the chlorine? Now, once all the chemical formula have been written out correctly, and it's written out correctly, then you balance it by adding numbers in front of the chemical. So it's 2HCl, not Cl2 anymore, but 2HCl. So you add the 2 in front of the HCl. So this is how we write a balanced chemical equation. Okay, so if you follow my steps, my first step is actually writing the correct formula. I ensure that I balance out the positive and the negative ions charge, write the correct formula, then I start balancing and counting the number of atoms. Okay? Now, we can practice with another metal and another acid. So this is another metal, right? It's zinc this time around, and you have nitric acid. So how would you then write the formula of the salt? Okay, so look. Okay, and think through. Okay, I want all of you to try on your own. Now, so I hope you have figured out the equation. First things first, zinc plus nitric acid. If it's zinc plus nitric acid, it forms zinc nitrate. All right. Now, zinc nitrate, how do you write it? Now, you must first know that zinc forms Zn2 plus. Nitrate is NO3 minus. So again, the charges don't balance out. So in order to balance out the charges, I will need two nitrates. And this is how you express it. Bracket NO3, 2 plus hydrogen, H2. Okay? Now, a common trick which always applies is to balance the nitrate as a Lego brick, as a block. So to balance the nitrate means I have 2 HNO3. In fact, you see, okay, once you do this and you are familiar with it, you can actually balance relatively quickly. Okay? So importantly, you must have realized that zinc nitrate, zinc is Zn2 plus. If you realize that it's Zn2 plus, first hurdle crossed. Next, you need to know nitrate. Nitrate is NO3, 1 minus. If you knew that, another hurdle crossed. Then you must know that, okay, so I need 2 nitrates. Therefore, I bracket up the NO3 and put a 2 there. Okay? So these are some common equations, common examples of acid plus metal. Okay? Which gives you salt and hydrogen. Now, that's the first reaction of acid. The second reaction of acid is acid plus base. Okay, we mentioned that acids and bases are opposite kinds of substances. So when you mix an acid and a base together, they react to give you salt and water. Okay, so acid plus base gives you salt and water. And this reaction is known as neutralization. Now, why is this reaction known as neutralization? That's because salt and water formed are both neutral. Okay, so example, again, come up with examples. Acid, okay, acid is like HCl, hydrochloric acid. Now, what is a base? A common base in the lab, sodium hydroxide, NaOH. So HCl plus NaOH. It forms salt and water. So what is the salt? The salt must be sodium because the metal here is sodium. And because you use HCl, the salt is chloride, sodium and chloride, sodium chloride plus water. Then you can add in the state symbols if you want. These are aqueous substances. They're all aqueous. Except for water. Water is a liquid, it's an L. Okay? So this is a very common neutralization. Hydrochloric acid plus sodium hydroxide. Acid plus base. Now, this is the chemical equation for it. Right? The chemical equation is this. But very often, you are asked to write the ionic equation. So what is the meaning of the word ionic equation? Ionic equation means, okay, we only want to show the ions which have changed. If the ions didn't change, don't write it into the ionic equation. What do I mean by did not change? A good example is sodium. On both the left and the right side of the arrow, the sodium remains as Na+. It's Na+ on the left. It's also Na+ on the right. So sodium did not change, and therefore sodium should not go into the ionic equation. Ionic equation should only show the ions which have changed. So what has changed? I think quite obviously you can say H+ has changed, OH- has changed. On the left-hand side of the arrow, it was H+ from the acid, OH- from NaOH. It has changed to what though? It has changed to form water. So the ionic equation for neutralization is just H+ aqueous plus OH- aqueous forms H2O. So you need to know this. Okay, the ionic equation for neutralization is as such. All right. And that's acid plus base forming salt and water, neutralization. So we have gone through both the chemical equation and the ionic equation. Okay, so moving on to the third reaction, acid plus carbonate. Now, acid plus carbonate forms salt plus carbon dioxide plus water. Now, this is really crucial. Carbon dioxide gas. Carbon dioxide is a gas. Carbon dioxide in chemistry must always have come from a carbonate. There is no exception. CO2 must have come from a carbonate. Okay, so for my 4Care students and 5 Flourish students, you must be familiar with this by now. If it's CO2, the previous step, it was a carbonate. All right, so for my 3 Contribute students, I also stress this in class. CO2 comes from a carbonate. You need to know how to test for CO2. I believe just now, Madam Afana went through with 3 Contribute how to test for CO2. To test for carbon dioxide, we have to use lime water. We bubble the gas into lime water. Okay, so we bubble the gas into lime water. Now, if it's carbon dioxide, what do you see? You will see that the gas forms a white precipitate in lime water. Okay, so you need to know the test for the gas and the observations. So now again, let's make full use of this to practice formula writing. So again, let's use an example of an acid, HCl, hydrochloric acid. Now let's say that the carbonate that we use in this case is calcium carbonate. Okay, so now we're going to use a periodic table and go and find where is calcium. All right, calcium is Ca. So you can find your periodic table now. Look for calcium. Which group is calcium in? All right. So if you look at your periodic table, you will be able to find that calcium is in group number 2. So if group 2 has 2 outer electrons, if it has 2 outer electrons, it will lose these 2 electrons to form Ca2+. Okay, so if you are lost again, how to deduce the charges on the ions from the periodic table, please refer to my revision video from yesterday when we did ionic bonding. Okay, so group 2 is 2+. Okay. Now, carbonate, you got to memorize. It's CO3, 2-. And so, how do you write the formula? 2+, 2-. Are the plus and minus charges balanced out? They are. If the plus and minus is balanced out, then you just need to write CaCO3, meaning 1 Ca2 plus, 1 CO3 2-. Okay? So HCl plus CaCO3. So hydrochloric acid plus calcium carbonate. So once you know this, then now you got to figure out what is the salt. Now the salt form must always have a metal in front. So the name of the metal here, you can see on the left, the only metal here is of course calcium. So the salt name must begin with calcium. And because the acid you use is hydrochloric acid, the salt's name must end with chloride. So the metal is calcium, the acid is hydrochloric acid, and therefore is calcium chloride. Calcium is Ca2+, we already established that. Chloride comes from Cl. So if you look at the periodic table, Cl is in group 17, so it's forms Cl-, so it's CaCl2 plus CO2 plus H2O. Okay, so now once you have written out the formula correctly, then you can start to do the next step. So what's the next step? after you have balanced out the plus and the minus, which you have, the next step is to count how many of each atom do you have. So like calcium, you got one, that's okay. But Cl is not okay because you have two Cls on the right, you only have one Cl on the left. And therefore, we have to add a number in front of the HCl to balance out the number of Cl. Okay, so this is how we write the chemical equation of acid plus carbonate. Now let's practice. Okay. Okay, I'm going to tell you this carbonate is magnesium carbonate. So can you try writing the balanced chemical equation? HNO3 plus magnesium carbonate. What is the final product and how do you balance the equation? Now, once you are done, again, take a picture of your equation and show me. Okay? Okay, so hopefully all of you had a chance to try. So again, magnesium is found in group 2. So 2 plus is correct. Carbonate is CO3 2 minus. Okay, CO3 2 minus must be memorized. So it's MgCO3. All right. The formula of the salt must be magnesium nitrate's formula. All right. Why is it magnesium nitrate? Because you had used magnesium carbonate, so the metal is magnesium, and then nitrate because it's nitric acid. So this Mg2 plus and O3 minus. So this is where you're going to be really careful. One is 2 plus, whereas the other one is only 1 minus. So this is a classic situation whereby you will need to bracket up the nitrate because you have two nitrates. Okay, so magnesium nitrate is Mg bracket NO3 2. And then your other gases is CO2, H2O. Okay, so once you have this done, the formula written correctly, the next step is just to ensure that the numbers of each atom on both sides is the same. So NO3 is like a block. So you balance the block. So NO3 2 on the right. So on the left must also have 2 HNO3. Okay. And I'm sure by now you can see a very good pattern. All right. By now you should be able to see a pattern whereby, okay, you can see there's always a 2 in front of the HCl or 2 in front of HNO3. The reason, of course, is because we are using group 2 metals. Group 2 metals form a 2 plus charged ion. Okay? Can? Now, so look back at the equations that you have written. You have written many, many equations. Now, before we go on to bases, look at equations or chemical reactions 1, 2, and 3. There is a similarity between 1 and 3. Reaction number 1 and 3 are similar because acid plus metal and acid plus carbonate, they both produce a gas. Acid plus metal forms hydrogen gas. Acid plus carbonate forms carbon dioxide gas. Okay. Now, in the lab, if there is a gas formed, what do you see in the lab? Okay. You cannot see there's carbon dioxide, but you see bubbles. And another word for bubbles is effervescence.
Effervescence.
So acid plus metal gives you effervescence. Acid plus carbonate also gives you effervescence. So this is how the two reactions are similar. The two reactions are similar because they give effervescence. Okay? So for my 4K students, hopefully, all right, you have seen the equations that you've written. Hopefully today was also a revision for you in equation writing. Okay, so now we are going to move on to bases, which is the second type of chemical substance. We will go through quickly what's the reaction of a base. Okay, and we should be able to end off today very nicely with types of oxides. Okay, so I'm going to move on back to bases. So we have covered everything about acids so far already. The definitions, physical properties, chemical properties. Now let's go to bases. Now bases, you might look more complicated, but in reality bases, it just means metal oxides or metal hydroxides. Meaning the name already tells you whether it's a base. If you got a metal then with oxide or metal with a hydroxide, it's a base. All right. So for instance, magnesium oxide. Magnesium is a metal. Magnesium oxide is a base. Calcium oxide, base. Hydroxides, sodium hydroxide. Sodium is a metal, so sodium hydroxide is a base. Potassium hydroxide, base. Because potassium is a metal. Calcium hydroxide. Why calcium hydroxide got OH2 suddenly? Again, this is a consequence of the formula. Calcium is Ca2 plus because it's group 2. Hydroxide is OH minus. So to balance out the plus and the minus, I need 2 OH minus. Okay? Now, so metal oxides or metal hydroxides are bases. But what do? They are metal oxides or hydroxides that react with acids. Base react with acid. Opposites react together. Base plus acid, okay. Opposite react together. Okay? And when they react with acid, they form two things. Salt and water only. Okay, so acid plus base becomes salt and water only. Okay, so bases, that's a definition. But you have also learned in Sec 2 probably this word called alkalis. So what are alkalis? Now, alkalis are soluble bases. That means they are bases. They are metal hydroxides, for example. But they must be soluble in water because you must produce hydroxide ions when dissolved in water. Okay? So they must dissolve in water. And when they dissolve, they form hydroxide ions. That's the definition of an alkali. Okay? Now that you know what is base and what is alkali, so the only difference between base and alkali is alkali must be aqueous. Base don't need to be aqueous. Okay? Now, this leads to an important conclusion. It means that the physical properties that we learn, for instance, alkalis, turn, moist, red litmus paper, blue, right? You have learned this in Sec 2 probably. This is only true for alkalis because it must dissolve in water. If it doesn't dissolve in water, it will not change the color of litmus paper. If it's a solid, the litmus paper stays the same color as before. It's not going to change. Okay? Can? So that's a physical property. Turns moist red litmus paper blue. Next, alkalis turn universal indicator blue or purple. Okay, we have learned this before. So blue or purple again depends on the pH. Blue is like pH 8 to 11. This one is like 12 to 14. All right. So most of your lab alkalis, like sodium hydroxide is a very common alkali, is at pH 14. Okay. Now, those are the physical properties that you should know by now. Now, we go on to the chemical properties, and this one is the one that is quite straightforward because you have learned already the first one. Acid plus base from salt and water. So this is neutralization, right? Because it forms salt and water. But it's the second one that we often forget. Okay, I'm sure the second one. Okay, now that I say it, you probably will remember it. Base plus ammonium compound forms a salt, ammonia gas, and water. Okay, so this is another reaction that has effervescence, another reaction that has a gas formed. Ammonia is NH3. All right, ammonia is NH3. How do you test for it? You test for it by placing a piece of moist red litmus paper at the mouth of the test tube. So this time around, we are going to use moist red litmus paper because we know ammonia is actually alkaline. Ammonia gas being alkaline, it will turn moist red litmus paper blue. Okay? Now, this reaction, many students will forget. So please try not to forget, okay? Base plus ammonium compound forms the salt, ammonia gas, and water. Okay? So now, again, we can practice writing equations here. So a common base that you have around you, okay, could be sodium hydroxide. Right? Sodium hydroxide is a common base. Ammonium compounds that are common around you. For instance, ammonium chloride. Now, what is ammonium chloride? What is ammonium in the first place? Ammonium is NH4 plus.
Metal.
Okay, it's not really a metal, but it forms a cation ion. Okay, so it's NH4 plus, so it's Cl minus. Okay, so can you please take note? Ammonium is another one of those ions that you all must memorize. And I think you all always get it confused with ammonia. So ammonium is NH4 with a +1 charge. So ium. So one way to remember, okay, it's like a metal, right? Metal like sodium. Sodium also plus what? So ammonium is also plus. Okay, it's a cation ion. Very good. So now what salt will it form? So now you're going to think. I keep saying, right, salt means it must start with a metal. So what's the metal? The metal in this case is actually sodium. Okay? Then what is the second part? The second part must be either chloride, nitrate, or sulfate. So in this case, chloride, because you have Cl. Okay, so it's sodium chloride plus ammonia gas plus water. Okay, so this is the equation for the reaction. Now, how do I know that this is already balanced? Now, this is already balanced because I can easily count. I have one sodium on the left, one sodium on the right. One chlorine on the left, one chlorine on the right. Finally, one NH4, one NH3. Now, this is a pattern. If you have one NH4 on the left, you will form one NH3 on the right. So where did the last H go to? Where did the extra H go to? The extra H actually went to form water. So the NH4 plus forms NH3 and the last hydrogen goes to water. Okay, that's just for your knowledge. Now, another common base in the lab as well as in industry is calcium hydroxide. Okay, so Mr. So will write in words because now I want you to translate this into chemical formula. So we have calcium hydroxide plus ammonium chloride. What is formed? What is formed, remember, is the salt, ammonia gas, and water. So what is the salt? Again, you look, The metal is calcium. So the salt's name begins with calcium. So it's calcium what? Remember, the second part of the name must be either chloride, nitrate, or sulfate. In this case, chloride. So in a sense, they are exchanging partners. Calcium was with hydroxide. Now calcium go with chloride. So it forms calcium chloride, ammonia, and water. Okay, so now that I've written in words for you this equation, can you try converting this to a chemical equation and balance the chemical equation for the reaction between calcium hydroxide and ammonium chloride? Now, so I hope, okay, all of us have had a chance to try writing the chemical equation for this particular reaction. Now, this particular reaction is just an example of base plus ammonium compound. So base like calcium hydroxide and ammonium compound like ammonium chloride. Okay, it forms salt, ammonia gas, and water. Now, I've deliberately chosen these compounds because each of these compounds has its own uses in industry in our daily lives. Okay? Okay? Now, so let me bring you through how to write. So I think all of you have managed to write up to this stage. Okay, so very good. I think most of you are you are more familiar with it now. You know that, okay, CaOH2, you know it's CaCl2. Now, the first step, of course, is you need to balance out the number of chlorines. This gives you 2 NH4Cl. You need to put a 2 in front of the NH4Cl. That's correct. That makes it 2 chlorines. All right. However, by putting a 2 in front of the NH4Cl, not only do you have 2 Cl, you also have 2 NH4. If you have 2 NH4 on the left, you must also have 2 NH3 on the right. So these two are linked. Okay, the number of ammonium on the left is equal to the number of ammonia on the right. The next thing which is also linked together is the OH. If you look at the pattern so far, if you got 2 OH on the left, you must have 2 H2O on the right. All right? So the number of OH directly equals to the number of H2O on the right. And this is how you balance this equation really quickly. Okay, because I know that I need 2 NH4Cl to balance out the Cl. Once I see 2 NH4, I know there must be 2 NH3. Okay? If I see 2 OH on the left, I will have 2 H2O on the right. Always. It's a pattern that you learn. Okay? Now, I've chosen these compounds because these compounds are also useful for something. Ammonium chloride is a fertilizer for soil, for the plants to grow better. Now, calcium hydroxide is important. It is a base that is added to neutralize acids in the soil. So calcium hydroxide is a base, and this base is what is added to soil to neutralize the acids present in the soil. Okay? Can? So we don't just add random bases, must be calcium hydroxide. Now, I think 3 contribute, you probably heard this from me already. Why don't just add any other base? Why must be calcium so specific? Okay, these are plants. Plants grow in soil. You can't just possibly just throw any type of base in, you know. Plants they have certain requirements, all right? You cannot just throw whatever, you know, you want in, or else the plant doesn't grow. In particular, you can't throw sodium hydroxide into the soil. Number 1, sodium hydroxide too alkaline, the plant will die. Okay? Not only do you neutralize the acid, you make it so alkaline, the soil, the plant dies. Number 2, sodium ions are toxic to the plant. All right? So by throwing sodium hydroxide into the soil, basically you have sodium ions. Sodium ions are toxic for the plant. So magnesium hydroxide, how come cannot? Because magnesium ions are also toxic. So there are many ions which are not very well tolerated by plants. Calcium happens to be one of the ions that's more well tolerated Hence, calcium hydroxide is the base that's added to neutralize soils. Okay? Again, however, we should not add the calcium hydroxide and the ammonium fertilizer at the same time. Okay? We should not add the base and the fertilizer at the same time to the soil. Why? Well, you actually just wrote out the reason why. The equation tells you why cannot add them at the same time. Because if you added them at the same time, they react together. How do they react together? Well, you have written the equation for it. You just balanced it. They react together to form ammonia gas. Right? Calcium hydroxide plus ammonium chloride becomes calcium chloride plus ammonia gas plus water. So they react together to form ammonia gas, which, okay, to you maybe it's not a big thing, but actually this escapes from the soil. That's logical. The gas won't stay in the soil, right? The gas will escape. And if it escapes from the soil, it causes a loss of nitrogen from the soil. The formula of ammonia has nitrogen inside it. So if ammonia gas escapes, it's equivalent to saying nitrogen is escaping. If nitrogen escapes, then you got less nitrogen left in the soil. What's the big deal? Well, nitrogen is needed for plants to make proteins. Without nitrogen, plants don't make proteins, plants don't grow. Okay, so the nitrogen is important. So after you form ammonia gas, it escapes, your nitrogen is lost from the soil, which means that your plants will not grow very, very well as a result. Okay, so today we have covered the whole chapter of acids and bases up till neutralizing soils pH. So how do you neutralize acids in soil? We will add calcium hydroxide. However, we do not add calcium hydroxide and the ammonium fertilizers at the same time because of this reason. Okay, so the only part of acids and bases left that we have not covered is actually types of oxides, which we will aim to go through another lesson. All right, so let me stop the recording here.